So I recently got the opportunity of using AMD AI Resource Manager. So it basically provides you a graphical user interface to manage your existing Kubernetes cluster, which has AMD GPUs in it, and you want to use it to run some workloads or deploy some LLMs or something. So let me straight away show you how the user interface looks like. So when I ran through this, when I used AMD AI Resource Manager myself. So I took a lot of screenshots when I was in the process, and I have pasted all the screenshots here, and I have also written description around it to explain how to use the platform. So this is how the you could say the landing page looks like. Here we have the menus: dashboard, clusters, project, secret, storage, and users. We will be exploring each one of these menu sequentially. So first we have clusters and nodes. So we only have one cluster, and that one cluster only has one node, and that one node only has one GPU as of now. And that one GPU is NVIDIA MI300X, which has 191 GB of VRAM. And we also have one project which is sitting idle, meaning it hasn't been allocated to any cluster yet. So because of that reason, the GPU utilization is at 0%, zero working running workloads, and no pending workloads as well. Because this is a freshly created cluster and none of the projects have been assigned yet. Now, if you click on the documentation page, you can straight away jump to the AMD's website, which has in-depth information on how to use the enterprise AI suite or how to set it up for your own cluster. And this entire guide that AMD has created goes into a lot more detail than this video covers. So I would highly recommend for you to go through this if you want to set it up for yourself. Then out of all the menus that we have, when we go to the dashboard menu, we get to take a look at what's the GPU memory utilization and device utilization. So memory utilization is about how much VRAM of the GPU is being used, and GPU device utilization is like how much of the GPU's SM processor time is being used. SM processor is a streaming multiprocessor. Yeah. So how much of that streaming multiprocessor is being used to execute some workloads, like in time, how much CPU cycles have been allocated. So that was the dashboard page. Next, we can go to the cluster menu, which basically shows us how many nodes and how many GPUs are present in each node. So here we have only one node, and out of that we have one GPU, but here we can see zero allocated GPUs because none of them have been allocated to our project just yet. So the demo cluster is our name of the cluster, and all of the utilization sits at zero because everything is running idle as of now. Then we can also go to the we can also click on the cluster to go to the cluster details page. Here we get the same GPU device utilization, but the only difference is that it gives you an aggregate view. Let's say your cluster has 4 GPUs, so it will give you the aggregate GPU utilization across those 4 GPUs in your cluster. That's the difference. And here, as you can see, the cluster has been assigned to a project, meaning a project will be able to use this cluster, but inside this cluster, none of the GPUs have been allocated to the said project. Then we can also go to the project menu here. So as you can see, we have another project created which is demo, and the cluster that we have, demo cluster, has been allocated to this project, and it is ready to be executed here. We can also create new projects here, and we can filter projects based on the cluster they have been allocated to or the status, whether it be pending, running, or finished. Then we can click on the project to get more information about the said project, which is our project named demo. So here, as you can see, here the project is also idle, and we have no workloads running under this project. GPU device usage is 0, and VRAM usage is also 0. And all of this data is for 1 hour. You can also increase the time frame to either 1 day or 7 day, and you can go to project settings to configure the settings in your project. Then you can go to the project settings to change up some parameters, which are you can change up the quotas for the project. So what quota is, it is basically the minimum guaranteed resource that your project can get. Let's say your project needs one GPU at any given point of time, and our cluster only has 4 GPU. What setting a quota basically means is that the set amount of resources is always guaranteed for us to use. No matter how many other projects are trying to access resources in your cluster, the amount of GPUs, the amount of CPU cores, the amount of RAM that you have specified will always be available to you. But that does not mean that you cannot exceed that quota. Let's say you have allocated 128 GB RAM as your quota, and your program requires 256 GB. Now, if the overhead RAM that is required by the project, if it's available in the cluster, then it will be allocated to you. But the additional usage will never be guaranteed to you. And the counterpoint is also true. If you haven't allocated anything in your quota, let's say you have allocated 0 GB RAM as your quota, but your application uses 16 GB, that does not mean that your application won't get any RAM at all. It will get RAM based on the availability in the cluster. If RAM is available, then it will be provided. Then, if not, then no RAM will be provided, as we haven't specified anything in the quota. So now after that, what I did was I specified the quota. Yeah, GPUs as 0, 10 CPU cores out of 24, and 55 GB of RAM out of 126 total, and for approximately 40 GB of disk space out of 144 storage. Then we move on to the secrets menu. So secrets is basically a way of storing API keys, because the thing is, if you store the API keys in your program, and if you're uploading your programs to, let's say, GitHub, your API keys may get leaked. So instead of storing your API keys in your program, you can also store it in your env file, and secrets are just an alternative to having a .env file. Here you can add a project secret, you can give it a name, you can type in your secret, and you can define the scope and the use case for it. So that's exactly what we are going to do. We are going to create a new secret key, and the secret creation menu looks something like this. We choose the type. It could be external, internal. Then the usage context, it could be generic. It could be, let's say, you're storing your Hugging Face token, or you could be storing your min.io token. So what is min.io? Min.io is like an open source implementation for Amazon S3. We want to store data, but we don't want to lose the sovereignty of our data by giving it to by uploading it to AWS servers, so we can use their own implementation locally using min.io. So if your cluster wants to access your data in min.io, you would need a API key. So that API key can be stored in the secret as well. As you can see, external and internal secret, Kubernetes secret. Then we have options Hugging Face, database, generic, S3 bucket. Then comes the storage menu. So we have two kinds of storage here. One is permanent, and the second is ephemeral. So let's say for our cluster, I have allocated 500 GB hard disk. So if the storage type is ephemeral, so as soon I restart the my cluster, the storage will be gone, and all the data in it, data stored in the 500 GB hard disk, will also be wiped out. But if the storage that we are using is permanent, the data will persist across restarts. So that's the difference. So here we are not using a typical hard disk based storage, we are using min.io. Basically, we are using a local implementation of S3 bucket. That was for our storage part. And as I said, instead of a traditional hard disk or an NVMe drive, you can always use the abstraction layer, which is the S3 bucket. You can attach S3 bucket as your storage source. And as you can see, we currently don't have any buckets available here, because the S3 bucket that we have created has already been assigned to our project, which is named demo. Then you can also remove storage from the said project, which is our S3 bucket. And next comes the user tab, on what users are able to access this project and run their own workloads. So we have only one user here, which is the dev environment user, which I created for testing purposes. And you can also invite other users via email to get access to this project. As I said, inviting other users. And then if you go to the general settings of the project, you will get information like what should be the name of your project, what should be the description, and what cluster has it been allocated to. And if you want to delete your project, that is also something that you can do here. Then we have another secrets menu. So how is it different from the secrets menu that we looked at before? So the secrets menu we looked at were project specific. So all of the secrets that you have created will only be accessible inside the current project. But the secrets that you have created outside in this bigger menu, it will be accessible across every project. So that's the difference. Rest everything is same about the secrets that we have created. Even the storage is same. The same logic applies. The storage that we have created for our project can only be accessed by the said project. But the storage that we created in the outside menu can be attached to any project of your liking. And here for storage, if you're trying to create an S3 bucket, you'll need a name, you'll need a URL. As you can know, if you are exposing AWS buckets publicly, you can have a URL which you can use to access the contents of the said bucket. So we can have a bucket URL for internal or external access. Then we can use a secret to store the API key, and we can assign it to a particular project. Then again, the users menu, but in the organizational context, we still have the same one user. The only difference is that you can configure the settings for each user in this panel. As you can see, you can change the user's first name, last name, email ID. That's not of much importance, but you can also assign roles and permissions. That is accessible here. As you can see, in our workspace, we have two types of users, which is a platform administrator and a team member. So we are choosing platform administrator as our role, and we can also invite new users to our organization via email as we did before. So this was entirety of what you can do with AMD AI Resource Manager. I'll be exploring more such technologies in the future, and I'll be documenting everything that I do.